From here? Okay. So, firstly, I want to hear a bit about you guys because I'm not all that sure. I mean, I didn't just arrive today. So, can you just give me a rough idea? How many people here from Canberra? Okay, most. New South Wales. Okay, Victoria. West Australia. Queensland. Okay, Tassie. Yeah, and South Australia. Okay, so I get that. Now, I want to hear a bit about where you're coming from. So how many of you would read on a regular basis, say once a week, Hacker News? Slashdot, TechCrunch, IT News, The Register. Okay, there's a bit of a chunk down here. How many people would read Stack Overflow? Okay. Okay, so how many people would have actually worked in a startup? Okay. How many people have worked in a job where they've been doing programming? Okay. How many people have worked in a job where they're doing some aspect of IT other than programming? Okay, system administration. Okay. Well, obviously it's a fine line between those. Okay, that's good. How many people here have made a pledge to a crowdfunding site like Kickstarter or Possible or Indiegogo? Okay, quite a few. That's good. How many people here have started a project on Kickstarter or? Okay. How many people have actually made a pledge on one of those crowdfunding websites and actually got the thing that they made a pledge so they could get? Okay. Good. Okay, great. Gives me a bit of a rough idea. So what we're going to be talking about today is the technological ecosystem that leads to the innovations that we use every day. Now, you probably heard 2 weeks ago Apple released the iPhone 5S and the iPhone 5C and iOS 7. And one of the big features of the iPhone 5S is the Touch ID. So you can put your thumb onto the iPhone as a means of authentication. Now, of course, everybody sort of sees that coming out and they go, "Wow, Apple's got some great new feature," or people see it and go, "Gee, Apple's got some new sucky feature." Yeah, but you know, what isn't the case? People might think, "Oh, well, Apple's been working on this back in their labs for years and years and come up with this new technological innovation." The reality is usually much more complex than that, and there's usually this rich ecosystem behind any of these innovations that we see in our daily lives. In that particular case, Apple bought
There you are. If you can talk at that one, and I'll just give you a minute.
No worries. So, and then, just carrying on that thing, innovation is not simply invention, it's invention put to use. Invention without innovation is a pastime. Now, it's going a little bit far probably, because, invention is a critical part of innovation, but it's, a lot of people, it's not enough just to do the invention part. Okay, how's that? Yep. And here's one that is actually quite a common definition of innovation. Invention is the conversion of money into ideas, and innovation is the conversion of ideas into money, which I actually don't like very much, but it's commonly used. It gives you a rough idea of it's reasonably accurate, but of course, Tim Berners-Lee, for example, who I think is responsible for the most important innovation in the last 25 years, he wasn't doing it for money. Obviously, it generated money, but not specifically for him. He did it to make the world a better place. So why is innovation important? Obviously, there's, you can address national issues like reducing carbon emissions, finding alternative energy sources, some of the stuff that Bob talked about and Pascal talked about the other day, improving disaster response. Also, improved standard of living and so on. But I think it's pretty obvious that innovation is important to society. Of course, it has its downfalls. When there's a new innovation, it will sometimes have downsides as well. But innovation is also really important to companies. Here's some data from the Australian Bureau of Statistics and from last year, where they've interviewed. There's a survey they've done with a whole bunch of companies, and it's a little bit hard to read there, but I'll sort of summarise it in another slide. But what they did is they interviewed companies and found out which ones were doing innovative activities and which ones were not doing innovative activities. So here's the results. For the companies that were innovating, they were 42% more likely to be profitable, 3 times more likely to export, 4 times more likely to increase the range of goods and services offered, not surprisingly, 2 times more likely to increase employment, 3 times more likely to increase training for employees, and 3 times more likely to increase social contributions. That's just in Australia. So if you're going to, for those of you who want to go out into the workforce, it's probably best to choose an innovative company, right? Don't go and work for a company. You need to choose a company that's going to be a good company to work at. If you go to somewhere where they're doing active innovation, then you're going to find that there's so much more that will be possible there. Now let's get back to Schumpeter. So he came up with this concept of innovation as creative destruction. You hear that term sort of come back into use just recently. You hear it quite a lot now, creative destruction. So what was the idea? He was, through all his analysis, and he analysed hundreds of companies, he found that there was a bit of a myth that people thought that the world just sort of, innovation made things a bit better and a bit better and a bit better and a bit better. It's this nice sort of flat but slowly improving economy. But what he found was it was just this raging torrent with tumultuous things happening where companies were continually being created and other companies were being destroyed, and there's just this thing constantly happening. And it's like it became quite. He found all these patterns through in the way this creative destruction is being done. And so that's why he coined the term creative destruction. And he was basically saying innovation is like it's propelling something through the economy with this sort of tumultuous stuff happening all around it. But he always traced it back to single people. There were individuals like you guys who were entrepreneurs. And entrepreneurs doesn't mean people that just make startup companies. There are entrepreneurs in large companies. It's people who actually try to make change. They'll take risk and try to make change. They don't necessarily have to have the money. They're the people that make the tough decisions to actually make change. And all companies react adaptively to change. But for companies that were actually doing creative responses to change, they're the ones who where there were entrepreneurs inside those companies doing creative acts to change. So if you end up in a company in your career where you're just, something comes along and you react to it, that's not the way to do things. You need to identify, try to understand the landscape, provide some creative reaction to the situation, and that will lead to innovation that can create new companies, create new industries. Yeah, and then often there'll be a technological breakthrough, and after that technological breakthrough, whole new companies emerge. So let's now just drill into IT innovation, which is obviously a special type, but it's not just like any innovation. IT innovation is special. It's what some people call general purpose technology. And it's like electricity. So an innovation in IT or in computer science isn't just going to improve computer science. It actually improves a whole lot of other things above it. So like innovations in electricity can lead to other benefits. General purpose technology is the idea it's pervasive across many industries. It's continually improving in its usefulness and lowering cost, and it can spawn innovation in other areas. So here's a sort of just an example of, here's information communication technology at the bottom, and it's supporting all these industries. And you can have innovation inside those industries or innovation in IT that drives change in those industries. If you look at what's big at the moment, we've got a lot of innovation in broadband use, a lot of innovation in big data, mobile, social, cloud, green IT, and so on. And many more, of course. And all these innovations are actually having a massive impact on all of these industries above them. It's not just, we're in this little industry ourselves and our innovations affect us. We're actually affecting the whole industry. Couple of examples, fairly random. Actually, I probably don't need to go into examples because Bob's already done that. I'm showing that big data analytics can improve water pipe. The likelihood of predicting water pipe failure, or can find places to find geothermal energy, and so on. So I probably don't need to go into details. As Bob said again, there's so much data now, and so much of the progress that's happening now is data analytics. So, for example, bioinformatics. We've got a chromosome, of course, and that's represented as a genome. And of course, the genome is data, and we can use computational approaches on genomes, of course. And even when the SARS coronavirus outbreak was happening, it was computational techniques. Analysing that was used to people wrote software that processed the genome that ended up finding what species that coronavirus was similar to, and through doing that they found out the actual species that had initially spread the coronavirus. Similarly, they found out the history of the virus. They found out the geographical dispersion. So this is just one example in health, how at the core of the innovation that's happening in health is largely IT related. Similarly with smart traffic control, fleet logistics, so on and so on. Even cars now, high-end cars now have 100 microprocessors, up to 100 million lines of source code on a high-end car. And software development is 15% of the total cost of a new car now. What does software do in a car? It does the airbag system, the alarm system, cruise control, and so on and so on. Most of the time building a new transmission system of a GM car was 70% of the time was actually spent on software development. And then, so some experts in the automotive industry have said that for modern cars, 80% of innovation comes from the software and computer systems. So the point I'm making is that, it's fairly obvious, I'm sure you all know it, but software is out there in every industry, and innovations in software are out innovating in every industry. Now, this idea of creative destruction, let's look at IT innovation. I know I don't need to say it, you probably all know it, but improvements in IT can change whole industries. Look at the media industry. This is creation. This is the creation of a new industry in online advertising, going from back in 1999 through to 2012. And just you can see there's a creation of a whole new industry of online advertising. But in parallel with that creation of that new industry, you have the destruction of another one. This is print newspaper advertising revenue during that same period. Now, these are nice figures showing there are people doing online advertising are getting a lot of money. People who are doing print newspaper advertising are losing money. But it's more complicated than that. There's actually this whole supply chain behind each of those. It's not just companies being created, it's industries being created who have relationships with each other to supply the need for this new industry. And in the old industry, it's not just one company losing staff. There's a whole supply chain. There's the people who make the paper, the people who make the ink, the people that adjust print heads. There's a whole supply chain that has been massively disrupted and completely changed. And this is what IT is doing again and again now. And it's really just starting. We're really at the start of software disrupting the world. Some people may know this Mark Andreessen, and who knows this famous article, Why Software is Eating the World? A few people, yeah. So a couple of years ago, back in 2011, he wrote this article, Why Software is Eating the World. He was saying that, he was actually, this is the guy that wrote the Mosaic web browser back in the mid-90s, and he's now an investor, or very, very, very well-regarded investor in Silicon Valley, investing in Facebook at a very early stage, Groupon and so on, Twitter. But he basically said what he was trying to do in the mid-90s was, build a web browser, and he built Mosaic, he built Netscape, he actually started the Netscape company. But back then it was too early, but now we're at a point where the technology works well enough, it can be delivered globally. And this is because on the front end, you've got billions of people with smartphones. Billions of people now have smartphones. At the back end, you've got software tools that can launch not just a little website, but global software-powered startups. And you don't need any infrastructure. So we could go out there, we could sit down now and create a globally relevant company in a couple of hours. If we were lucky, we'd have to be pretty clever about it, but you can do it. That wasn't possible 10 years ago, or 5 years ago. Now, what he showed in this famous article was he went through all these examples of how software is eating the world. He said the largest bookseller in the world isn't a book company; it's a software company. So Amazon, obviously. And while Amazon became the largest bookseller in the world, Borders went bankrupt. So Borders was a bookshop. Amazon's not a bookshop; it's a software company. The largest video service in the world is a software company. So Netflix. So Blockbuster, which was a video retail and rental chain, went bust, whereas Netflix, which is a software company, is now the biggest video service. Dominant music companies are now software companies. Apple, Spotify, Pandora, and traditional record companies still exist, but they're there. They're there to serve the software companies. Apple's not just a software company, of course, but and the fastest growing game company is a software company. This is 2011. This is a bit dated now. So Zynga, and the largest direct marketing company is a software company, obviously Google. So, and it goes on to show other examples where the companies that are really succeeding now are software companies because you've got this front end with billions of people, and you've got a back end that's easy to start a company and grow quickly. So, where do good ideas come from to feed innovations? I'll just play a little bit of a video. I'm just going to go into this a bit. Yep, go for it.
At least as much time, if not more, valuing the premise of connecting ideas and not just protecting them. And I'll leave you with this story.
Interesting. Okay, that's great, isn't it? Sorry.
Story, which I think captures a lot of these values, and it's just a wonderful kind of tale of innovation.
So just a bit of background. So this is, I'm just going to play the last couple of minutes of this video. Feel free to go off and see it. This is
happens in unlikely ways. It's October of 1957, and Sputnik has just launched. And we're in Laurel, Maryland, at the Applied Physics Lab associated with Johns Hopkins University. And it's Monday morning, and the news has just broken about this satellite that's now orbiting the planet. And of course, this is nerd heaven, right? There are all these physics geeks who are there thinking, oh my gosh, this is incredible, I can't believe this has happened. And two of them, two 20-something researchers at the APL, are there at the cafeteria table having an informal conversation with a bunch of their colleagues, and these two guys are named Geyer and Weifenbach. And they start talking, and one of them says, hey, has anybody tried to listen for this thing? There's this, man-made satellite up there in outer space. It's obviously broadcasting some kind of signal. We could probably hear it if we tune in. And so they ask around to a couple of their colleagues, and everybody's like, no, I hadn't thought of doing that. That's an interesting idea. And it turns out Weifenbach is kind of an expert in microwave reception, and he's got a little antenna set up with an amplifier in his office. And so Geyer and Weifenbach go back to Weifenbach's office, and they start kind of noodling around, hacking, as we might call it now. And after a couple of hours, they actually start picking up this signal, because the Soviets made Sputnik very easy to track. It was right at 20 megahertz, so that you could pick it up really easily, because they were afraid that people would think it was a hoax, basically. So they made it really easy to find it. And so these two guys are sitting there listening to this signal, and people start kind of coming into the office and saying, wow, that's pretty cool. Can I hear it? Wow, that's great. And before long, they think, well, geez, this is kind of historic. We may be the first people in the United States to be listening to this. We should record it. And so they bring in this big clunky analog tape recorder, and they start recording these little bleep, bleeps, and they start writing down the kind of date stamp, time stamps for each little bleep that they record.
Yeah.
And then they start thinking, well, gosh, we're noticing small little frequency variations here. We could probably calculate the speed that the satellite is traveling if we do a little basic math here using the Doppler effect. And then they played around with it a little bit more, and they talked to a couple of their colleagues who had other kind of specialties, and they said, geez, I think we could actually look at the slope of the Doppler effect to figure out the points at which the satellite is closest to our antenna and the points at which it's furthest away. That's pretty cool. And eventually they get permission. This is all a little side project that hadn't been officially part of their job description. But they get permission to use the new UNIVAC computer that takes up an entire room that they'd just gotten at the APL. And they run some more of the numbers. And at the end of about 3 or 4 weeks, it turns out they have mapped the exact trajectory of this satellite around the Earth just from listening to this one little signal, going off on this little side hunch that they'd been inspired to do over lunch one morning. A couple of weeks later, their boss, Frank McClure, pulls them into the room and says, hey, you guys, I have to ask you something about that project you were working on. You figured out an unknown location of a satellite orbiting the planet from a known location on the ground. Could you go the other way? Could you figure out an unknown location on the ground if you knew the location of the satellite? And they thought about it, and they said, well, I guess maybe you could. Let's run the numbers here. And so they went back, and they thought about it, and they came back and said, actually, it'll be easier. And he said, oh, that's great, because, see, I have these new nuclear submarines that I'm building, and it's really hard to figure out how to get your missile so that it will land right on top of Moscow if you don't know where the submarine is in the middle of the Pacific Ocean. So we're thinking we could throw up a bunch of satellites and use it to track our submarines and figure out their location in the middle of the ocean. Could you work on that problem? And that's how GPS was born. 30 years later, Ronald Reagan actually opened it up and made it an open platform that anybody could kind of build upon, and anybody could come along and build new technology that would create and innovate on top of this open platform. Left it open for anyone to do pretty much anything they wanted with it. And now, I guarantee you, certainly half this room, if not more, has a device sitting in their pocket right now that is talking to one of these satellites in outer space. And I bet you one of you, if not more, has used said device and said satellite system to locate a nearby coffee house somewhere in the last day or last week, right?
So it's a reference to something earlier, because he was at...
And that, I think, is a great case study, a great lesson in the power, the marvelous kind of unplanned, emergent, unpredictable power of open, innovative systems. When you build them right, they will be led to completely new directions that the creators never even dreamed of. I mean, here you have these guys who basically thought they were just following this hunch, this little passion that had developed. Then they thought they were fighting the Cold War, and then it turns out they're just helping somebody find a soy latte. That is how innovation happens. Chance favors the connected mind. Thank you very much.
Sorry, the reference there to coffee was at the. He starts off talking about the coffee houses in the UK were sort of the place where people started meeting and discussing ideas, which actually led to a lot of the Industrial Revolution, to a lot of the ideas that formed the Industrial Revolution. So that's Stephen Johnson. He actually analysed a lot of different innovations, and this is a chart of his that divides them into 4 quadrants. So there's the top 2 where the innovation was deliberately devised for a fiscal gain, to make money. And the bottom half are ones where it wasn't designed to make money. So, for example, the ones in the bottom are ones typically done in universities or by individuals, or through people just trying to do good things for the world. The ones at the top typically done by companies. But then if we look at the left versus the right, on the left-hand side, it's where it's an individual who's largely done it. So, for example, down in this bottom quadrant, you'd have things like the World Wide Web, which is actually here. Sorry, you can't see these, I know. But the World Wide Web here, where you've got an individual doing it not for monetary gain. And down here are ones where it's networked. So you have a number of people in a networked environment running ideas past each other, trying to generate ideas together. And so his main point here is just see how many more there are on the right-hand side and see how many more there are on this bottom right quadrant. From his analysis, most of the innovations that actually get out and get used in the world, so we're not just talking about good ideas, we're talking about actual innovations that have got out and got used in the world. Most successful innovations have come through people networking together and not trying to do it for fiscal gain. The openness of innovation frameworks is sort of something I'll be talking about a bit more today. So how does the innovation happen? So some people talk about this thing called the innovation system. So there is a system. You can put anything into a sort of system model. This is a particular one that came out of a Japanese ministry. I quite like it because it's nice and simple. So at the bottom half you've got the government, at the bottom. Actually, no, that's not true. At the bottom you've got society. You've got the environment, culture, tradition, national character, which influences the next level, which is politics and economy, which influences the next one, which is government. And then the government puts in place a whole lot of regulations and framework because the government wants innovation. I was saying earlier that innovation is really important to society and to countries. So the governments want to encourage innovation. I mean, the fact that you guys getting an education where the government puts money into education, not enough obviously, but it is part of the government support for the innovation system. The fact that the government provides R&D tax incentives to encourage companies to do innovation is another example. Having labour market policies and things like that. So those are all the things that the government does to try to encourage innovation. Then up the top you've got this idea of a knowledge base that's continually being added to, particularly by universities and research institutions. And then you've got companies that are using the innovations and getting them out into the world and getting demand, getting ideas from the market, producing products, and then working with universities where appropriate so they can actually build new products. And I quite like this model. I mean, it's simplistic, of course, but it sort of does capture some of the key relationships. And the importance of this middle relationship between universities and research institutions and companies is critical to this working. So I'm going to sort of come back to this slide a few times today. These are sort of the main players in the innovation ecosystem. I'm sure you know about all of them. You've got universities, you've got research organisations, open source developers. You've got established technology companies and startups. And startups are not just small companies. They're actually a different type of beast completely, and I'll talk about that. You've got investors who are investing money, particularly in startups, and placing bets on those startups. We'll talk about that too. But the users are equally important. You've got technology using companies and individual technology users who are very much part of that ecosystem as well. So before I get down into details of those different players in the ecosystem, let's just look at some patterns of technological innovation. There's certain patterns that you can see if you actually analyse how innovation happens. So firstly, how do innovations spread? You may have seen this before. This is from a guy, Everett Rogers, who came up with this in the 60s, and it's still widely used today. And so this idea, he was an agricultural scientist, and he noticed that when farmers were adopting new innovations, there were some farmers who would just adopt a new, say a new seed type, a new crop type, a new fertilizer or something new. There were some who would just get the new thing as soon as it was available and start using it. There were some who would wait to see if it was popular, and there were some who just sort of never got around to doing it at all. In fact, his father was a farmer, and his father was very much one of these guys, which sort of inspired him to come up with this whole model. But he then analysed a whole lot of different industries, and he found that no matter what industry he looked at, there was always a very similar pattern, that there were your early adopters, your innovators, the people doing the innovation, the early adopters who would, innovating and using the technology, others that were the early adopters, and then eventually get the early majority and so on. And there were characteristics that he found of these people. And the characteristics weren't always obvious. I mean, for example, the early adopters were not necessarily great promoters of a technology. They'd often be adopting it for their own use and wouldn't necessarily go and advertise to the world they're using this. In fact, you were often more likely for the early majority to start doing that. And there's certain characteristics that people had. Now, if you take that same sort of data and plot it cumulatively, you end up with this thing, which is called the technology adoption S-curve. And it's the same data, just done differently. And this gets used a lot in talking about the adoption of technology. You can see, I'll just jump to here. This is some technology adoption S-curves, where you've got the blue one here is colour TV, the red one here is cable, and so on. And you can see that the adoption of technology, as you've got closer to today, the S-curves are getting steeper and steeper. So it's showing that technologies are getting adopted much faster today than they have been before. So that's one pattern. Another pattern is how technologies improve. Companies will typically, when a new technology comes out, and it might be the speed of a new processor, it might be the memory, it could be the accuracy of a new speech recognition algorithm. Typically, over time, the performance of that algorithm or the performance of the technology will improve following an S-curve like that. And this is because early on in the life cycle of a technology, there's not much being invested in it. And over time, as soon as people start realising it, that this is worth investing in, it gets more effort put into it, which means it improves more. And it starts improving exponentially. You get to a point where it starts levelling out. And you can see that in all sorts of technologies. Here's just some examples from the efficiency of different energy sources when plotted against how much money is invested in those energy sources. And again, here's luminous efficiency as well. So that's pattern 2. I'll come back to some of these later. So now pattern 3. There's some technologies tend to become dominant. There was a guy who did a lot of study of the automotive industry and found that what happened was, as the automotive industry became mature, a dominant design started becoming in place that meant that components could be shared between, we had open interfaces and so on. So if you look at a car now, you've actually got large numbers of suppliers who supply components into that car. And this is the same in software. And there's actually a mechanism by which that happens, and we could see that happening for the PC. If you look at the IBM PC, the IBM PC, for those who don't know, came out in about 93, and IBM spent 6 months developing it. And what they did is before that, there'd been a whole lot of computers, personal computers like the Amstrad and the Amiga and the early Apple computers, and each of those was custom made. The concept of dominant design is that when products are first introduced, they're made to order. So you end up with a product which, a lot of the components will be custom and built specifically for the purpose it was built for. What happens, of course, is if a product is successful, other companies copy it. And this is true of hardware or software. Once companies start copying, they start releasing competitive products. But because every company is under pressure to reduce costs, they're always looking for how they can bring some of the components in from third parties to introduce into their design. Again, true of hardware or software. And so you get commoditization of components, and you get opening up of interfaces. And what happens is you form what's called a dominant design. So the dominant design becomes the design for that type of product. And who actually comes up with that dominant design could be the first company that came up with the concept. It could be the second. It could be later. IBM were not the first company to produce a personal computer, but they established the dominant design. And then that becomes the base for the whole industry. So once it becomes established, other companies don't need to go off and do things from scratch. They'll just use whatever's there. So with the IBM PC, of course, they used standard memory, standard disk drives, standard everything, and made it as open and specified the standard, made the standard available to others. And that became de facto. Now, if you look in IT, the IBM PC architecture is an example, but so many others, like TCP/IP stack, the core web standards, the LAMP stack, RDMS. There's any number of dominant designs in the industry. Now, why do these dominant designs happen? They sort of what happens is companies get good at building software within that dominant design. So let's say you're talking about the LAMP stack. Companies have staff who get experience at using that, so they're more likely to build with that, so they're more likely to use third-party components that fit in with that. It's true now, just as much now as it was for the LAMP stack. Like, for example, JSON, for example, everyone is now using JSON for sending data to JavaScript. There are other ways to do it, but everyone starts using that. They learn how to do that. They become good at doing that. There become more products available that help you do that, and so it becomes a dominant design. You also get network effects where you've got if you've got different services that connect up to each other, you end up getting those standards well embedded. That leads to better connectivity and compatibility and so on. And also sometimes the government will get in and actually standardise a dominant design, like in Australia for digital TV, where the government came in and said, we're going to use the DVB-T standard in Australia, and then the whole industry sort of fits around that. So the fifth pattern is, there we go, is value networks and how they change over time. So a value network is this idea that in an industry, once you have a dominant design, or even if you haven't got one yet, the industry sort of sets itself up with a value network. So it's like a concept of supply chain. You probably know this concept of supply chain. Value network's the same thing, but it's a bit richer in its representation. Here's an example of a typical value network in a technology industry, where you've got value flowing from different parts of that network to other parts. Here it is for healthcare. Now, what you find happens in an industry when you have a dominant design is that innovation, the type of innovation that's done, changes. So once you have a technological discontinuity, so say a new technology comes out, say it's a new, let's say it's a new type of way of doing gesture control. What will happen is there'll be this, what's called an era of ferment, where all these companies try to become the owners of that space, that control that new technology area. And you get competition between different designs until you get to a point where the dominant design is established, and then what you get incremental innovation. So during here, you tend to get quite radical innovation. During here, you get quite incremental innovation. So we've talked about some of the patterns in society and in the market and the industry. Now let's get back to the innovation ecosystem. Research organisations, I'm not going to talk more about universities. I assume you know about universities and know about research in universities. The research organisations like NICTA, they're different from universities typically because not only are they doing research, but they're also trying to get that research out into the world. If you look at this is NICTA's research groups. Here we've got the machine learning group that Bob runs. Over here, you've got business teams that are engaging with industry. NICTA's model is to actually find industry problems, take research, develop solutions, and get them out the door being used. It's quite it's been found to be quite a successful model now, with a lot of new technology that's been out and now being used in the world. But let's get on to established technology companies. So in Australia, there's quite a large, well, there's a reasonable number of companies who are doing software research and development in Australia. So most of those companies you will have heard of. All of those companies there are doing software research and development in Australia, doing innovation with software. There are others as well. At the top of the list, you've got ones that are largely, large multinational companies like Canon, IBM, Google, and so on. As you come down the list, you're getting to smaller Australian companies like CiSRA Research, who you may have heard of, but who have shrunk in recent times. But then down to companies like Atlassian, Freelancer, and Optiva, who are now sort of more newer generation companies starting in Australia and now growing and becoming multinational companies. If you're interested in careers in software development and innovative companies, these are all good companies to work for, but also there's a growing number of smaller companies starting up now and a very rich ecosystem. We'll come to that shortly. So in existing companies, the traditional way of doing innovation has been using what's called an innovation funnel. And this is the idea, it's fairly dated now, I think, but people still use it in large companies, is the idea that you have lots of ideas coming in, and then you have a small number of those ideas are selected for further funding for development. A small number of those will become major development. A small number of those will be launched as products, and then some of those will be successful. And the reason I'm not so keen on that model is it's sort of really almost defeatist. You're sort of saying, oh, we're going to have all these ideas, we're going to just sort of try them and see what happens. It's sort of implying that there's not an active strategy to engage with an end market and end users and improve things as you go. Another model that's frequently used now, which is sort of based on that funnel idea, is what's called the open innovation funnel, where it's not so closed. You've got, some of your ideas will come from inside a company, some of your ideas will come from outside the company. Some of your technology will come from outside the company, some of your technology will actually move out from your company to be licensed to other companies. But the idea is that you are part of an innovation ecosystem, and there are lots of companies within that innovation ecosystem, and it's a much more open environment. Again, another traditional approach, this is similar to the funnel approach, and again, I'm not so keen on it, is the stage gate approach. But this is very widely used in industry. If you work in a large company, you're very likely, even now, to be using something like a stage gate approach for innovation. The idea with stage gates is you have stages, and there are gates. Okay, so you might have, for doing innovation, you might start with an idea screen. If it's a good idea, you give someone a little bit of money, let them go and scope it. If that gets through a next screen, you might give them a little bit more money so they can build a business case. If they get through the next one, you give them a little bit more money. And so the idea is there's someone in control of some money, allocating that money out as resources for someone who then goes and does something. And then testing, validation, and launch. Can anyone see what's wrong with that sort of model? I mean, it makes a lot of sense, and a lot of companies use it. So it's sort of not obviously wrong because people successfully use it. But
got potential barriers in innovation.
yeah, I mean, well, there's a whole lot of things wrong with it. But one of the things, so it's, for a start, you're assuming that these screens are affecting, that there are people who know what's going to work and isn't going to work. And typically those might be sort of managers in a company who are people who control the money, and they might not be the people in the best position to know if it's going to be successful. But the other thing is, well, I mean, it's not obvious from this, but usually it's the case that you don't have users till you come out here, and that's way too late. You should be talking, you should be trying things with users from the start, and I'll get onto that in a minute. So, speaking of users, let's now look at technology users. So there used to be this concept that innovation was done and this goes back to Schumpeter's day, that large companies had large R&D labs who did innovation in these R&D labs, hidden away from the world, and they were the ones that did the innovation, and then eventually some product was released, would come through some product development process and be released as a product to the users who would love it. What's become more, it's been realised over the years, and it's been happening for quite a while now, that actually the users often are doing the innovation. It's not, this is a move from the concept of producer innovation, that all innovation is done by a producer, to actually innovation being done by users. And classic examples people use this idea of high performance windsurfing. It used to be that there were windsurfers, there were boards that you held your sail on, and people started modifying them and started realising that they kept falling off when they tried to jump over a wave. So people started strapping their feet onto the boards, and then everyone started being able to jump over more waves and have a better time. And so all the users started doing it, just modifying their own boards. And then the companies realised, oh, hang on, that's a whole new category of product called high-performance windsurfing, and they basically started releasing products. I mean, it happens a lot with sporting gear, because sports people are usually early adopters. People who really love their sport are often early adopters and will modify the gear that they have. But it's the same with software. A lot of people will modify their software. So here's a classic example. Apache, the Apache web server. What was happening back in the early days of the web, there was NCSA, the place which Mosaic, the web browser, came out of. They also developed the first widely used web server, which is called HTTPD. And that was being used by a lot of websites. But it was just developed by a guy, Rob McCool, at NCSA. And there was a whole bunch of webmasters around who started using it and tweaking it, because it was open source code, so people would change the code, make patches on it. And there were Rob McCool, the original author, left NCSA, and these guys were sort of a bit disappointed that the code wasn't being updated. They all had changes. There were 8 guys. They'd all made different changes to the code, and so they got together. They were all webmasters. So Brian Bellendorf here, he was a webmaster at Wired, the Hot Wired, the online version of Wired magazine. He was a webmaster. He modified his web server. He wanted to get together with the other people who'd modified their web servers and make a single web server, so they could all sort of benefit from each other's changes. So they formed Apache, and that stood for, at the time, it meant Apache Web Server. It was Apache Web Server with lots of patches, and they changed the spelling and it became Apache. And so that now, as everyone knows, it has most of the world's website run off the Apache Web Server. But it started by a bunch of users who were using it for their own means and then make changes. And you find this happens all the time in software. Look at MySQL. MySQL started by a couple of guys who were running a website, and they were using MSQL, which predated MySQL. But they were trying to use it for what they wanted. It just wasn't fast enough. They found that it just wasn't flexible enough or fast enough. So they basically wrote their own code with changes to it, but using the same API. And it became MySQL. MySQL was bought by Sun Microsystems for $1 billion. But they were users of something who innovated. People probably heard of Yammer, which is probably one of the world's most widely used enterprise social networking systems. That actually came from a company, Genie, who do genealogical. It's a genealogical website, and they built Yammer for their own use internally. And they had 20 developers. Those developers wanted to talk to each other, so they basically built this for their own use inside the company. And they, after a few months, they realised they had about 30,000 messages that they'd used internally using this, and they realised, hang on, this is actually better than the tool that we're using inside for our internal social networking is actually better than the product we're building as a company. So they actually spun that out, and that was bought by Microsoft for $1.2 billion a couple of years later, and now used by over 200,000 companies. So the one big change. So the world isn't one where there's these big producers who produce the products for the end consumers. The world is one where, particularly in software, it's the end users solving their own needs, building some software that solves their own needs, and going from there. So let's look a bit more at the some trends in this innovation ecosystem. So one of those trends is that moving from this closed innovation to this more open innovation. So if you look back at 1981, 70% of total R&D was by companies with more than 25,000 staff. Okay, and only 5% with less than 1,000. So most, 70% of R&D was by these massive companies. Where are we now? Well, in 2012, it's half that. So 35% of total R&D spending is by these large companies. So what's happening is this idea of these large R&D groups is really going away. A lot of these companies still have R&D groups. They're shrinking. You've got a lot of smaller companies. There's a lot more reliance on open source software. There's a lot more reliance on small companies building, specific, like feature as a service or just small components that are used within a larger company. Another trend is this one from producer innovation to user innovation. So some of the ways that it's not just that companies are now recognizing the importance of user innovation, so they're making it easy for people to do innovation on their platform. So this is why a lot of companies are now using open APIs, open data, crowdsourcing, and so on. Separating Wikipedia as commons-based peer production separately from crowdsourcing, open source, of course, and free and crowdfunding. So open APIs. So again, this is companies recognizing that they can't do everything themselves. I mean, it used to be that companies tried to, if you look at what Microsoft used to do or IBM used to do, they'd largely build their software and their product was their software, right? And it did everything you could possibly want. And companies did start opening up, releasing software development kits and APIs into their software. But now it's gone to the extreme, where a lot of companies will release. It's the API that really matters. There might be some service some online service that they provide, but really it's the API to other companies using their service that really matters to them. So here's the growth in APIs. So this is web-based APIs. If you look at where it's gone from 2000 through to now, it's just astronomical growth there. And what type of APIs are there? Travel, internet, social, mapping, and so on. Pretty much everything. Google Maps API, Facebook API. But pretty much any company that has a half-decent website is going to have an API to provide others with that functionality. So why is that? It's because it's now no longer the case that companies feel they need to do all the innovation themselves. It's a much richer ecosystem where people are sort of marking out a place where, this is the bit where they will maintain control and they can anchor themselves into their innovation system more if they just focus on what they're good at and just anchor themselves in. They can't write all the applications people could possibly want to do in their area, so they try to make it available for others to do. And then, just to show you the size of some of these APIs, this is the API Billionaires Club. This is about a year out of date now, but it's, Twitter, 13 billion API calls a day, Google, 5 billion API calls a day, and so on. I mean, even things like, even Cloud, billion API calls a day. And what are they using? So most of them are using RESTful interfaces. Open data, you probably all know, but if you, the federal government, the ACT government, New South Wales government, Victorian government, and so on, all of them have their open data websites, data.gov.au, data.act.gov.au, and that's becoming a very rich source of data that people can use to innovate around. This example here is a website based on New South Wales data that allows you to very easily compare different suburbs based on a whole lot of statistical information, but all done with open data. And crowdsourcing, of course. So crowdsourcing, as I'm sure you all know, is the act of a company or institution who taking some function that used to be done by employees and now it's being outsourced to generally a large undefined network of people in an open call. So this is the guy who actually came up with the term in a Wired magazine blog back in 2006. So it's not Wikipedia is not crowdsourcing. Crowdsourcing is where a company has a need for some functionality, for something to be done, and they make an open call, and lots of people respond to that. I might skip that. Open source software, of course, I'm sure you all know and love open source software. There's an increasing number of very successful businesses who have formed around releasing open source software. So gone are the days when companies used to, so for example, Red Hat, Red Hat became successful by releasing open source software and then selling its support services for that open source software. We've now moved to a world where there's many more opportunities to build successful businesses through open source software. So open source software can be being done for the open collaborative innovation that it provides, or it can be done as a strategic move for a potential business. Because the world's so big and well connected now, often the best way to get people to use your software is to open source it from the start. So if you open source it, you're more likely for people to pick it up. If you choose a very liberal license, like an Apache license or an MIT license or a BSD license, people are more likely to use your software for commercial purposes, but ultimately they will probably want to come back to you at some time to provide some additional value add, and that's what a lot of these companies are relying on. Companies like Hadoop, so Cloudera, so for those who don't know Hadoop, Hadoop for large-scale distributed processing, based on MapReduce, came out of, MapReduce was from Google. Yahoo developed Hadoop and it spun out, it was released as open source. The key people formed Cloudera to take Hadoop away from the web, instead of being used for large web properties, they target it for use inside companies. And so by using inside companies, those companies needed the additional assistance that those experts could provide, so that they actually justified having a company, even though their software was open source, and so on. And it's a very common model these days. Similarly with MySQL, when MySQL, again, open source software, but still was bought for $1 billion by Sun Microsystems because of its strong brand behind it. There's lots of different business models that are using open source these days, from the traditional ones like selling support and services through certified ones, through enterprise editions, lots use dual licensing, and so on. A lot of, but now the concept of open source, using open source for a new business is moving much more to providing services. So if you take something like a Facebook or a Twitter, a lot of the service they provide is actually using open source software with their thin layer on top. If you look at most cloud services, they are like that. So in some ways you could see them as open source business models in a way, because they're just people developers taking a whole bunch of open source software, providing some service, using that, having some edge, and making that into a successful business, and so on. Crowdfunding, quite a few of you knew about. What you may not know is that, so this is how successful the projects are. This is data as of today for Kickstarter. Kickstarter, 34% of their projects actually receive the amount of money that they seek. So when someone starts up a Kickstarter project trying to get funding for some initiative, making some gadget or something, so 34% of those projects are successful. Now that's ones that have got through the Kickstarter sort of barriers to actually become a project. But also surprisingly, there's actually 0 to 52% of projects, more than half of projects get from nothing. Quite a few get no dollars at all in Kickstarter projects, and up to 20%. So it's still, although crowdfunding is now a really democratizing the innovation system to allow people to provide money into someone to do something, to start some company or build something or make something or create something. It's still not a guaranteed way to do it, but still 34% is a pretty high percentage for success for those projects. Now, I said that established companies and startups are very different things. Now, one of the big problems that startups have had for years and years is that the people that used to run startups were largely people who'd done MBAs, learning how to manage large companies, trying to apply similar techniques to small companies. And just over the last 2 or 3 years, a bit longer, but mostly in the last 2 or 3 years, there's been a real science has developed for startups finally, so that now it's much more there is a new management science for startups which treats them separately. So Steve Blank is, who here knows Steve Blank, knows of Steve Blank? Okay, so Steve Blank is he's got a great blog if you're interested in startups, or particularly IT startups. He actually had several software startups himself. He's an engineer, not a management guy, but he calls a startup a temporary organisation in search of a scalable, repeatable, profitable business model. So the idea is that whereas a large company executes a business model, so they become good at executing that business model, and they can have really good operations and they can repeat things the same way all the time. A startup, it's always in an exploratory phase, so it's always just fundamentally different. Similarly, Eric Ries. Who here knows Eric Ries? Okay. So he talks similarly, a human institution designed to deliver a new product or service under conditions of extreme uncertainty. And this is a big difference. Large companies tend to execute in a situation where there's not high degrees of uncertainty. Small companies, there's so much uncertainty. Everything's uncertain. So established companies execute, startups search, and that has implications through all the processes of what they do. Here's sort of the traditional way that large companies develop products. This is similar to that Stagecoach approach, where you have a concept or a seed, then you do some product development, you do alpha beta test, and then you launch. Okay, it sounds sensible. Sounds pretty obvious. You got that concept set. You come up with some concept, you define a product and features, you work out who the customers are going to be, you do some market research, you develop a business plan. Then you start doing the product. You might go and interview potential users. You work out the requirements. You typically use a waterfall type model. Requirements, design, implementation, testing, maintenance, and then you start promoting it. And then you start doing the testing with real customers. You get feedback from the real customers. You tweak it. You start building up your sales and marketing. You get some channel partners, your distributors all lined up, and then you ship. Okay, you launch the product. Put press releases out. And this is a stock standard way that big companies do product development. And so what's wrong with this approach? I mean, it's still the most widely used way that companies build products and do their sort of large-scale product innovation. But what's wrong with this? I mean, saying,
They don't talk to their customers, right?
Yeah, I mean, they might talk to the customers, but they don't. But that's just a small feed into that process. Basically, it's assuming that you know who your customer's going to be. It's assuming you know who your market's going to be. It's assuming you're going to know what the functionality is. And there's this time period from the start to the end when the world's shifted in that time. And there's no way that what you thought at the beginning is going to be the same as the real world has changed massively since you actually had that concept or seed. So you need to have a much more iterative approach. And this is why a lot of companies now are moving to this idea of minimum viable products, where they try to get a product out as quickly as possible and then innovate around that through real world use. And it really suits the agile software development methodology. Steve Blank talks about the stack for startups is agile software development, a process I'll talk about shortly called customer development, and the business model canvas, which I'll talk about shortly. So here's the problem. The first contact between the product and the customer, I mean, you can talk to the customers earlier, but the first contact between the product and the customer is here, and that's way too late. And as Steve said, no business plan survives first contact with customers. So this is his approach. I mean, it's the idea is basically you spend time capturing a vision, and you develop hypotheses. So you come up with a hypothesis saying, okay, what if we built a product that did X? And then you work out an experiment to test that hypothesis. So it might be that your experiment doesn't involve writing code at all. It might be that your experiment is to go and ask a user, if we did this, what would you do? Or, would you do this? And you could just run a little experiment. And that could save you 3 months of time developing something if you find out there was no point doing it in the first place. But you keep validating things with customers and then pivoting to change. And so it's only when you've actually pivoted and validated something to show that it's scalable that you would then start actually building it out properly. And so Reid Hoffman, who's the founder of LinkedIn, says if you're embarrassed by your first version of your product, you've launched too late. So I'll just quickly show how are we going for time? Yep, I'll just show a short video of Eric Ries. So Eric Ries was highly influenced by Steve
If any of you
Blank.
made the mistake of turning your phones off, if you could undo.
So Steve Blank was on the board of Eric's company. I'm just going to play this video. It sums it up really nicely.
That and turn them back on. Please tweet amongst yourselves while I'm talking. I don't mind. All I ask is that you use the Lean Startup hashtag so you can join the worldwide conversation about these ideas that's happening 24/7. Okay, so we want to talk about what is entrepreneurship and how can we make it better. I thought it'd be good to start off with what do we all believe about entrepreneurship. So can I get a quick show of hands? Who has seen the best entrepreneurship movie of all time? I'm not talking about The Social Network. I actually mean this one. Who's seen Ghostbusters? Quick show of hands. Yeah, okay, everybody. So you know the classic story of the entrepreneurs. If you think about Ghostbusters, sure, there's some supernatural occurrences, but mostly it's a business movie. You got these guys in the lab. They come up with this great technology, too radical for their university. They get kicked out, and so they mortgage their house. They get the building, the car, the TV ad. That's all act one of the classic entrepreneurship story. Who's the plucky protagonist? What's their character strengths and defects that will be interesting later? And does anyone remember what's happening right as they start to get down to their last dollar in the Ghostbusters house? They're literally the day they're about to run out of money, boom, in walks their first customer. Anyone remember why their first customer walked in? Well, I'll let you know. It's because Zool is invading Manhattan with extremely good timing, if you think about it. Because if Zool invades Manhattan a year later or a year earlier, I mean, we'd be toast. Yet most entrepreneurs that I know are busy waiting for Zool, which we'll get back to. And then as soon as the first customer walks in, we can go straight into Act 2 of the entrepreneur story, which is the same in Ghostbusters or in The Social Network. I call it the photo montage. Generally lasts about 2 minutes long. There's no dialogue. And it's just, some guys pounding on computers, or in The Social Network, they have those cool pens you write on Windows on. They bust a few ghosts, they get a few customers, and boom, we can get on to the interesting stuff in Act 3, which is being on the cover of magazines, who sues who, how we divide the spoils, what kind of car you drive. The exciting parts of entrepreneurship. Act 1, coming up with a cool idea, being in the right place at the right time. Act 3, how do we divide up the spoils? What I discovered the hard way as an entrepreneur is that actually every decision of any importance that affects the outcome of entrepreneurs happens during the photo montage in Act 2. So why doesn't it make it into the movies? It's because it's too boring. Think about what happens in Act 2. It's the most boring stuff imaginable. It's product prioritization meetings. We never see the Ghostbusters having a product prioritization meeting, but they must have had millions. Right? It's deciding which customers to listen to and which to ignore. It's excruciatingly boring. And look, I know right now entrepreneurship is cool and exciting and everybody wants to be an entrepreneur, but the truth is, actual entrepreneurship, not like it's in the movies, it's unbelievably boring, painful, and basically humiliating. So we want to talk about the boring part of entrepreneurship today. Are you with me? So here we go. I have this new book out called The Lean Startup, and I wanted to talk about 5 principles from the book. First, entrepreneurs are everywhere. Entrepreneurship is management, validated learning, build, measure, learn, and innovation accounting. So I know you came for a cool talk about entrepreneurship, and now we're going to talk about management and accounting. So sorry about that. But I did forewarn you, right? So entrepreneurs are everywhere. If we're going to be more rigorous in the practice of entrepreneurship, it's important to start with a definition, so here's mine. A startup is a human institution designed to create something new under conditions of extreme uncertainty. It has nothing to do with how big your company is, as we just heard in the last session. It has nothing to do with what sector of the economy you work in. It only has to do with trying to create something new under these conditions of extreme uncertainty, which is a really fancy way of saying a startup is an experiment. But an experiment is not just, throw something on the wall and see what sticks. I mean experiment in the scientific sense, a hypothesis to be tested. And one of the things we try to do in entrepreneurship is reconceive everything that we do, every product feature, every marketing campaign, every customer we talk to, as an experiment designed to help us learn, are we on the path to a sustainable business? Which means that, unfortunately, entrepreneurship is management. But it's not this guy's management. And just as a handy tip, if you ever need to blame problems on anybody, it's helpful to pick somebody who's dead. So this is Frederick Winslow Taylor, who exactly 100 years ago invented the concept that we now call management. The management that we all studied in the 20th century that seems boring to us was actually unbelievably successful. It gave us all of the material abundance we have today. And the primary tools of that management were planning and forecasting. We all know that a manager who beats plan should be promoted, and someone who does worse than plan should be fired. But planning and forecasting require a long and stable operating history from which to make an accurate forecast. And quick show of hands, who feels like the world is getting more and more stable every day? Yeah, ha ha ha, right? Of course not. So why are we using tools that depend on stable operating environments to do the work of the 21st century that is much too uncertain? So we need a new kind of management. I call it entrepreneurial management, and the lean startup is an attempt to articulate that management paradigm. The most important concept in the toolkit of entrepreneurial management is this thing called the pivot. Anyone sick and tired of hearing about pivots already? Yeah, sorry about that. I apologize. I saw this the other day, kid you not, in the New Yorker magazine. I'm not leaving you, I'm pivoting to another man. So it's become a bit of a jargon buzzword. Sorry about that. But the truth is we can't say anything intelligent about entrepreneurship unless we have this concept in our vocabulary. Because if you look at the successful startups, they don't have better ideas than the unsuccessful ones. They have this very uncanny ability to, when they run into difficulty, pivot. Keep one foot anchored in what they have learned while moving the other foot one other thing at a time. So they don't just give up and go home, neither do they persevere the plane straight into the ground. And the premise of the lean startup is that speed wins. If we can have a way to extend our runway without having to raise money simply by getting to each pivot sooner. Now, the unit of progress of entrepreneurship is this thing I call validated learning, scientific learning about if we're on the path to a sustainable business. By the way, most of the companies that I've built have failed, which I know is not how you're supposed to start one of these talks as a professional expert, but anyone telling you the truth about entrepreneurship will be talking about failure. And the reason is because of this. Most of the time, startups are busy building something that nobody wants. And if we're building something that nobody wants, why are we so proud of having done it on time and on budget? See, when we make a plan and it's the wrong plan and we successfully execute it, then we have achieved failure. It's like we're driving a car off a cliff, but we're bragging about the excellent gas mileage we get as we go over the side. And if you go back to the idea that a startup is an experiment, this way of thinking unlocks a new way of being more efficient in a startup. It's not about how do I make more stuff efficiently. We live in a time where we can make anything that can be imagined. So the question of our time is not can it be built, but should it be built? And by treating everything we do as an experiment, we can start to ask the question, is there a faster way to learn what I need to learn? Rather than just build this product. That is the key. In a previous company, I spent 6 months building a product. I was the chief technology officer, so I cranked out this code. It was buggy and barely worked, and I was really embarrassed to ship it, and I almost didn't have the courage to put it out there, but I was like, well, I got to try it. So I shipped it, and I was really worried about what would happen, but turned out I was relieved because nobody would even download it. So nobody even found out how bad it was, and so at first I was relieved, like, well, phew, at least nobody found out my reputation is safe, and then I'm like, wait a minute. Why did I just spend the last 6 months of my life building something that nobody wants? I did it agile, it was very lean, it was all very efficient. It wasn't asking the right question. And as a result, most of us who are building startups are busy wasting people's time on an industrial scale. And it has to stop. Now, not you, I understand your startup is fine, but maybe the person to your left or the person to your right. Ask yourself, how do you know for sure that you're making progress? And that really is the really difficult question that entrepreneurs face. How do I know if I'm making progress? Because every day when I go home at night as an entrepreneur, what can I say for sure? I know for sure that I kept people busy. I know for sure that we hit product milestones, we made stuff, but how do I know if I'm making progress? So we need a concept that can help us make that evaluation, and so we call it the build, measure, learn feedback loop. Here it is. A startup is nothing more than a catalyst that turns ideas into products. And then customers interact with those products, enabling us to learn, and everything we do as a startup should be geared towards optimizing our total time through this feedback loop, going through it as quickly as possible. And there are a lot of specific techniques that are part of the Lean Startup. You can read the book or the blog to learn all about these. Each of these techniques has the local effect of allowing us to build or measure or learn faster, but I believe also has the net effect of optimizing total time. But I promised that I would talk about accounting, because I know we're all very excited about this very boring topic. And so I just want to mention one more concept from the book, which is this really deep problem of how do I know if I'm making progress? We like to laugh at the corporate CFOs that are constantly crushing startups when they buy them and constantly destroying and demoralizing internal innovation teams. We laugh at those people like, gosh, they don't know what they're doing. But the truth is they have a really deep problem. Because an entrepreneur comes to you and says, hey, give me $1 million in a year and I will come back and promise you tons and tons of customers. And flash forward a year later, what do we know for sure? We know for sure that the money got spent. Right? The money always got spent, but there probably isn't the kind of traction and success that was promised. And so how can a CFO, how can the person who's supposed to hold the entrepreneur accountable, how can they tell the difference between a team that is on the brink of success or one that has spent the last year goofing off. Our current tools can't tell the difference. We're not talking about A- versus B+, cannot tell the difference between abject failure and the brink of success. And so innovation accounting is an attempt to get us off of these product and business milestones towards learning milestones. So those are the 5 principles of the lean startup. I left a bunch of questions unanswered. I did that intentionally, of course, because I hear there's this really great book that just came out. Thank you all very much. Please be in touch. Thank you.
So, and I won't spend long on this, but so what Steve Blank talks about is that if you're a startup, you're doing this constant experimentation, but you're doing that experimentation to basically fill out this thing called a business model canvas, but we won't go into that today, which gives you a sort of a framework for all the experimentation that you do. So investors, startup investors is a really interesting concept. The idea is that an investor is putting money to a bunch of 2 or 3 people in the expectation that they're going to beat a large multinational company that has tens of thousands of staff, right? So that's what they're doing. They're actually putting money down for that bet. I mean, it's a pretty weird thing to be doing. So why do they have a chance? Why are they so prepared to actually take risk with a couple of people? But it turns out, time and time again, because of the ability for a small team of people to pivot and to stay focused, at any point in time and continually pivot, they can actually move much faster and actually build value in a way that a large company can't. And this is why they do it. And here's at the moment more than ever, the amount investors are more. There's more investment than ever going into these sort of startups, and this is because the size of things is getting so much bigger. I mean, if you go from back when you had mainframes, you had a few million units, then mini computers 10 million. PCs 100 million, but we're now up to mobiles, so smartphones, and so it's 10 billion units. So the scale at which things are happening now is so large that and given how easy it is to form a global company now with a couple of people, the potential payoffs are massive. And what investors do is they'll have a portfolio of different projects, some of which are high risk, high return, some of which are lower risk, but they'll maintain that portfolio so that they do actually allow them to get the odd sort of Facebook or Twitter out of their portfolio. So just to give you a sense of the investment, the types of investment in Australia for startups, there's angel investors who usually are founders, friends and families who will usually kick in the first sort of few tens of Ks. You then get angel investors who kick in more, and then venture capitals out here. There's different types of companies interested in different types of things. If you're a startup, typically you're just working often just with angel investors initially. There is this, I won't go into this in detail, but I can send around this link. This is a link done by a colleague of mine, a mind map, which is a mind map of the Australian innovation ecosystem. So what this shows is all the different, the incubators. So we can zap in and see. I mean, for those of you from Sydney, you can see all the different ones. Fish burners and so on. So incubators are ones where they'll take in some startups, give them appropriate mentoring, help connect them to potential funders and potential customers, and so on. There's some larger incubators that as well, and so on. There's also a growing number of accelerators, where accelerators are different from an incubator, and that they actually will be quite selective in who they take in and really try to drive that team to produce results very quickly. In some cases, the accelerator will take equity in startups, like for example Pollenizer. In some cases they won't, and so on. I'm not sure how many of you would be interested in this, so I can send the link around in case people want to just browse it. But enough to say that there is actually a very rich ecosystem now in Australia, obviously not as rich as Silicon Valley, but still very rich and with a lot of players. For those interested in this sort of area, there's probably Australia's most The best sort of conference for startups or people interested in startups is happening on the 29th of October, so next month in Sydney, and people from all around Australia will come to this. It's got some of it's called Tech 23, and typically it's 23 startups get chosen to present to an audience, and you can be in the audience. I've been to the last 4, and every time it's just been a really good day with pretty much the who's who of Australian entrepreneurs and investors and so on there. And it's a really good way to meet people in that space if you're interested. So that's 29th of October in Sydney. So, now to finish off, so how can you participate in all this? So, there's jobs in all of these places. I assume that some of you will stay at university, perhaps do a PhD, and even if you do a PhD, you might decide to stay at university, have an academic career. I think the current figures are around something like 20% of people who do a PhD stay in a university. So doing a PhD doesn't mean you're going to stay in academic. It's still more than likely that you'll go out into industry. If you're working in industry, you can choose to work in an established technology company or in a startup. You can choose to do your own open source development and hopefully make some business out of that. Or you could just, you could work in a technology using company and still be part of the innovation system by using new innovations and feeding back into those innovations. There's never been a better time to be in software, and there's more opportunities than you could possibly imagine. You've chosen the right thing to study. I'm assuming you're all studying computer science or IT or software engineering, and all of those are a good choice. There's any number of ways to change the world, not just changing computer science, but as I said before, changing any of the industries that rely on computing. I talked a bit about disruption. We haven't even really started disrupting yet. There's still large numbers of industries that are still, with the dinosaurs in their use of information technology. You look at the way contracts get done, you look at the way the whole legal system works, you look at the way education's now starting to be updated, but there's any number of industries that are still very early in their disruption, and there's a lot of work to be done by software developers and IT stuff. There's lots of jobs to get, there's lots of jobs to make, and so don't assume that when you're going off into a career that you're going to answer an ad for a particular job and get that job. You should be able to, because you're software people, I'm assuming, you should be able to make your own jobs, and it is easier than it's ever been to do that. Tell your friends, brothers and sisters to study computer science too. There's surprisingly, given the huge number of opportunities for computer scientists, it's unbelievable that there's not more people studying in Australia. It's just really quite shocking. And so, hopefully you recognise how important, that you have the best, you will have the best career of anyone you know, I expect. And there's so many opportunities. Please spread the word that everyone should be doing it. And that's it. If you're interested in any of those, I've got lots of references at the end. Any questions to finish off? Nope. Okay, well, we'll finish there. Thanks.